Hello everyone, welcome to our channel Study Buzz Official. So today we are going to solve a very important determinant related question. So the question goes like this. There is a 3 cross 3 determinant in which the elements are BC minus A square, AC minus B square, AB minus C square and so on. So the elements are pretty complicated and we have to solve it and tell whether the value of this particular determinant is always non-negative, non-positive, 0 or we can't say anything about it. So let us try and understand how can we solve such a question. Now try and understand this, that if you check out this BC minus A square, this looks like a smaller determinant in itself. Let me show you. Just check this out. If I have B, C, A, if you solve this 3 cross 2 determinant, that will be BC minus A square, isn't it? Simple, right? And similarly, if we check out the other one, which is AC minus B square, that can be written as AC B, which is nothing but AC minus B square. So we understand one particular factor, that these all elements are in a way smaller determinants. So when do we solve such smaller determinants? When we are trying to find out the cofactors of a particular element of a determinant. Now imagine these are alphabetical elements, always A, B, C, B, C, A, C, A, B. I'll just show you one thing. Suppose if I have a determinant delta which is formed by A, B, C, B, C, A and C, A, B. And suppose I have one more determinant formed delta 1 which is formed by the corresponding cofactors. Let me say the cofactor of A is something P, cofactor of B is something Q, cofactor of C is R and so on, X, Y, Z, W, R, T, something like this. So these are the cofactors. So this delta 1 determinant is formed by the cofactors of the corresponding elements. So there is a property which says that delta 1 is actually equal to delta square. It means the determinant found by the cofactors is actually equal to the square of the original determinant. Let me check whether I can make a good use of this property. Let's try and understand how can we do that. Suppose if I have the determinant A, B, C, B, C, A, C, A, B. Now let me try and understand whether all the cofactors are adjusted. Now the first element's cofactor is BC minus A square. This is my first element, right? And what is its cofactor? It will be plus only because it is the first element. So it will be C into B minus A into A, which is CB minus A square, which is CB minus A square. So that got adjusted. Now if you check out the second element, which is B, obviously the first element has plus, then minus, then plus. Such sign scheme is there for cofactors. So for the second element, it will be B square minus AC but with a minus sign. So that will be minus B square minus AC would be the AC minus B square. So AC minus B square. Do we see AC minus B square? Yes, we do see that. Now about the third, it is AB minus C square. Let's check out whether it also got adjusted or not. So that is this, adjust AB minus C square, right? For the third element, it is AB minus C square. Is it there? AB minus C square. And such all the elements have their corresponding cofactors placed at the current positions. For this B, it will be what? Plus minus plus. So it will be minus. So remove this, B square minus AC. So you need to have a minus. So that will be AC minus B square. Is it available there? Yes, it is there. So that is AC minus B square. So we can very surely say that this particular determinant which is given in the question is actually found by the cofactors of that particular determinant. So I can simply say that this is squared, because I already told you, if delta 1 is the determinant found by the cofactors and delta is the original determinant, then the relation between them is what? Delta 1 is equal to delta square. Now check out this is complete square, right? Complete square. Now complete square can be either 0 or positive, but it can never be negative. It means this is always greater than or equal to 0, and this is nothing but our question. So greater than or equal to 0 means it is never negative, right? It means what? It can be 0 or positive, which is non-negative. So correct answer to this question is non-negative. Now this particular skill set is very important when it comes to just checking out the elements and solving it orally. You should understand that this particular thing is found by the cofactors of a particular determinant, which is this, and then you can just express it as a square of it, and the answer will be non-negative. For such interesting questions we'll be coming back again. Thank you everyone for watching the video. Bye bye for now.